All right, good morning. It is Wednesday. Remember, tomorrow we have a CMS assessment. Make sure you're ready for the CMS assessment. The best way to make sure that you're ready for the CMS assessment is to go through your classwork packet and make sure that you know how to do everything from day one through today. So that's 10 days, days 1 through day 1 through day 10. Day 1 through day 10. If you've got that, then you should be good to go. So let's get started with the warm-up. The warm-up says determine the number of zeros for each quadratic equation. Hopefully we read and we realize we don't have to solve these things. All we have to do is determine the number of solutions. Remember again, zeros, roots, solutions, all exactly the same thing, just different ways of saying it. And what do we use to determine how many solutions a quadratic has? That's right, it's your discriminant. Remember that your discriminant, which is what we learned about on Friday, is the part of the quadratic formula that is under the radical. It's under the square root sign. And that would be b squared minus 4 times a times c. b squared minus 4 times a times c. And the value of that will determine how many solutions we have. So let's try this one. In the first example, we have a equals 1, b equals 10, c equals 12. It is equal to 0, so that's off of our little checklist. And so we end up with b squared, 10 squared, minus 4 times 1 times 12. We're going to punch that into our calculator, which I did not have ready. So there's that. So we end up with 10 squared minus 4 times a times c, and we end up with 52. That means we have a positive discriminant. If you have a positive discriminant, then you have two roots. Positive discriminant, you have two roots. Remember also, if that positive discriminant is a perfect square root, then you have two real rational roots. You have two rational roots. If it's not a good square root, if it's an irrational root, then you have two irrational roots. Here we go, same thing. Number 2. In this case, a is 1. Remember, you always look for the a as the coefficient of x squared. In this case, there is no b value, so the b value is 0 and the c value is 4. So exact same thing. b squared, 0 squared minus 4 times a times c gives us negative 16 as the discriminant value. If your discriminant is negative, you have no real roots. No real roots for number 2. Moving right along. A is 4, B is 20, and C is 25. So again, we end up with b squared minus 4 times a times c. This we're going to go ahead and punch into our calculator as b squared minus 4 times a times c. And it's 0. If your discriminant is 0, you have only one root. If your discriminant is 0, you have only one root. The only way that you can only have one root, one solution, one 0, one x-intercept is if that x-intercept is your vertex. So in this case, your solution would be the same value as your vertex. Last one. Again, we're making sure that we're always in standard form. Which gives us an a value of 2, b value of negative 5, and c value of 2. So again, into the discriminant formula we go. Negative 5 squared minus 4 times 2 times 2. And we end up with 25 minus 16, which is 9. In this case, again, it's positive, which means there are two roots. And by the way, they are both rational. I didn't ask you to find that, but I'm just reminding you that if your discriminant is a good square root, is a rational square root, then your two roots are also rational. So let's get started with today. Here's the thing. Today we're going to talk about word problems, and y'all have been doing word problems for quite some time. The difference now is that obviously these word problems are going to create quadratics. They're going to create, for the most part, quadratics. You still have to follow the same rules we've always followed with regard to how we set these things up. And again, if you'll remember, and I know that I've talked to my kids about it quite a bit, Remember, you cannot solve, if I write the equation x plus y equals 6 and ask you to solve it, you cannot solve that. There are far too many combinations of x's and y's that equal 6. However, if I write this, then it very much becomes solvable. Your goal is to write equations where only one variable is represented. Those are the kinds of equations you can solve. If you have two different variables, you cannot necessarily solve that equation. So here we go. A square has a side length of x. The minute I see that it's a shape, I would strongly suggest you go ahead and draw that shape. If the sum of the area and the perimeter of the square is 221. So we know we have an equation because we see is 221. So sum of the area and the perimeter. Okay, so let's find the area first. The area of a square is a side squared, or length times width, however you want to do it. So the area is x squared, x times x. The perimeter of this particular shape, given what we've labeled, is x plus x plus x plus x, or 4 times x. So in order to create the sum of the area, x squared, and the perimeter for x, we end up with an equation of x squared plus 4x equals 221. We have a quadratic. So now we need to go ahead and solve the quadratic. And in order to do so, we need to first set it equal to 0, which means this guy's got to move. So we subtract 221 from both sides, which gives us x squared plus 4x minus 221 equals 0. We go ahead and do a times c. Go to our handy-dandy calculator. We're going to let it do our factoring for us, because what we're looking for are two numbers whose product is a times c, which is negative 221, and whose sum is positive 4. So we're going to roll down through all of our factors in our table, and we find 13 and 17 as factors of 221. So factors of 221, we find 13 and 17. We look to see what their sum has to be positive. That means that 13 is going to get the negative. 13 gets our negative, so we end up with negative 13 times 17 and negative 13 plus 17. And both of those fulfill the requirements. So in this case, I'm going to go ahead and just do the grouping method. So I'm going to replace this with negative 13x and positive 17x. So I end up with x squared minus 13x plus 17x minus 221. Split it down the middle. X times x minus 13. We move our x minus 13 to the right. We fill it out on the front end, which gives us two factors of x plus 17 and x minus 13. Those have to be equal to 0, meaning our solutions are x equals negative 17 and x equals positive 13. Yay, we've solved. Now, here's what I need you to understand. We're going to go back up to our original shape. Now, here's the problem. In a regular quadratic, those are absolutely solutions. However, this dude is a problem for me, because you cannot have the length of a square, or any other shape for that matter, as a negative value. You can't have the side of a square being negative 17. It's impossible. Measurements cannot be negative. Therefore, x equals 13 is the only true solution to this particular word problem. I'll repeat again. They love geometry, mixing it into algebra during quadratics, because they're hoping that you pick either negative 17 or, worse yet, positive 17 as a solution. Let's try another one. The length of a rectangular blackboard. Rectangular. Let's draw our rectangle. The length of a rectangular blackboard is 7 feet longer than its width. That gives us an equation. Now remember, we would normally label a rectangle as length and width. However, this time, we have this little equation that tells us that the length actually equals the width plus 7. So we're going to substitute W plus 7 in for the length, which gives us that single variable. Now we only have W's. It tells us later on in the equation, in the word problem, that the area is 120 square feet. That means that the length times the width, or W, times W plus 7 equals 120. So again, just to kind of describe this, this is our width times our length equals our area. Only instead of using L, we use that W plus 7. So now we go through a normal equation solving process. We're going to distribute, which gives us W squared plus 7W equals 120. We're going to set this equal to 0 by subtracting 120 from both sides. So we end up with W squared plus 7W minus 120 equals 0. Remember, all I did is subtract 120 from both sides. And here we're on our merry way. Again, we're looking for factors. So we go to 100. We're looking for two numbers that when multiplied together, get you negative 120, and when added together, gets you positive 7. We find 15 and 8. 15 and 8. Because the sum is positive, we'll give 8 the negative, so we end up with these guys, which gives us W squared minus 8W plus 15W minus 120 equals 0. Split it, GCF plus 15, which gives us our factors of W plus 15 times W minus 8. Remember, all that is equal to 0. We use the zero product property rule, which gives us a width of negative 15 or a width of positive 8. Now remember again, these no bueno, no negative values. Therefore, the width of our rectangle is 8 feet. 8 feet. So we know, because we solved for W, that the width is 8 feet. Now here's where you have to be careful. Go back to the question to make sure you're asking it. Ask what are the dimensions. That means we also want the length. And if you'll remember, the length is the width plus 7. That makes our length 15 feet. Make sure you're answering the questions, please, guys. Make sure at the end of the day you do all this work and actually answer the question that's asked. Let's try one more. One more. Now, if you remember all the way back to Unit 3, when we were writing equations, we talked about the product of two consecutive odd integers, the product of two consecutive when we're talking about consecutive numbers, if we're talking about just plain consecutive numbers, then if we start with x, then the next logical number is x plus 1. That would give us two consecutive numbers. But in this case, they say two consecutive odd numbers. Now, no matter what you look at, whether it's odd or even numbers obviously being 2, 4, 6, and 8, etc., odd numbers being 1 and 3 and 5 and 7 and etc., that what separates each number from the next is the addition of 2. Therefore, to write two consecutive odd integers, we would need to start with an x, and then we would need to add 2. This is, guys, how you algebraically represent two consecutive odd or even integers. So what it says is the product of these two guys, which means x times x plus 2. The product of these two numbers is equal to 30 more than the first. 30 more than the first integer, which is x. So the product is equal to 30 more than the first. So x plus 30. I'll give you a second to take a look at that. Make sure that our equation represents the words. The product of two consecutive odd integers, that's this side, is equal to 30 more than the first integer. That's this side. Remember 30 more than? Remember that than guy? That's our flip dude. So here we go. Just an equation. It's just going to take a little while. So we distribute first, which gives us x squared plus 2x equals x plus 30. Now we want to move everything because we want it all equal to 0, so I'm going to subtract x and I'm going to subtract 30 from this side and move them to this side, which is going to give me x squared, remember plus 2x minus x gives me plus 1x minus 30 equals 0. All I did is move everything over. Now I'm going through the factoring process, looking for two integers that add to get us positive 1 and multiply to get us negative 30. And we find that those numbers are positive 6 and negative 5. Positive 6 and negative 5. Those two numbers get us what we need. So we do our box method, double distribute, whatever you want to do, grouping. So we end up with x squared plus 6x minus 5x minus 30 equals 0. Split and solve. X times x plus 6. We have x plus 6 on this side, which gives us minus 5 here, equal to 0, which gives us x minus 5 times x plus 6. Remember, those are our factors. Remember the difference between factors and solutions. Factors help us find the solutions. Zero product property rule tells us that x equals 5 makes that equal 0, and x equals negative 6 makes that equal to 0. Ooh, bad negative. Therefore, we cannot consider that to be an option. Plus, let's be honest, it's not an odd integer. Remember, at the very beginning, we knew our solutions had to be two consecutive odd integers. Well, we have 5 and negative 6. Negative 6 is out. Oh, it's actually, it's not out because it's a negative. It's out because it's even. It's out because it's even. An integer can be negative. An integer can be negative. But an odd integer cannot be even. Therefore, 5 is our option. We come back up to the top. Our first integer is 5. Our first integer is 5, which makes our second integer 7. And let's see if it meets our requirements. The product of two consecutive odd integers is 30 more than the first integer. Well, 7 times 5 is 35, which is 30 more. Therefore, ladies and gentlemen, here we are. So a couple things to keep in mind as you jump into your classwork and your homework. If you have a geometry problem, remember the rule with geometry problems is you cannot have negative measurements. So make sure you're going through carefully and setting up your equation, but you're eliminating any solution that can't happen. Remember when you're doing consecutive integers or consecutive even integers or consecutive odd integers that you're being very careful to set up your equation properly, and again, that your solutions meet the original requirements. And finally, guys, last thing, then I'll let you go. Very last thing, you have a test tomorrow. You have a test tomorrow. You need to make sure that you have gone over all your notes and your classwork from this unit. It is a CMS assessment. You know how those usually work. They are not multiple choice, and they are going to test how well you know what you're talking about. Anyway, get started on your classwork. Keys should be out, and then jump on your homework. Have a good one.